Hi, this is Steve Barton. I want to start today by giving a big thanks to Randy Richards. He gave us a shout out in his latest video, and we really appreciate it. It was kind of a surprise to me. I didn't know he was going to do that. I was at work on the first break watching some YouTube video. Noticed that our channel had a lot of subscriptions in a short time. And then the next break came a couple hours later. The subscription rate just went up, and so I knew something was going on when I got home. I checked on our site, and a few of the viewers mentioned that Randy Richards sent them our ways. And so I went and I saw in his video, which we're going to put a link to, but he gave us a shout out at the very end, and we appreciate that, all the new subscribers and viewers. And that video that Randy did, if you haven't seen that, I would encourage you to take a look at it, because he did an awesome job. He starts out after he finished grinding the magnetic chuck on his grinder, getting her real nice, and then he finished up by grinding a square setup block, and the precision that he achieved on it was really good. It was just a really good video. I encourage you all to watch it. But anyhow, Randy commented when one of the videos we did when we were doing our spin fixture and showing the jig grinding of some of our blocks and some of the features that you can use with this. We were actually working on these little setup blocks, and as you can see, I have 6 of these, and I've never really went out of my way to make these. In some of my previous jobs, we would make components for things, and sometimes they would be out of spec and they would be scrapped, and they would throw these away. I would just grab them, I would take them, I would heat treat them, and then I would grind them up, and then they work great because you can always use them for little parallel setup blocks. You got little bolt holes in here, you can bolt them on other blocks. The things just come in handy. So anytime I see any blocks like this that just being tossed away, and if the company allows it, I will take these things and I'll make tools out of them. I've done that now for probably close to 40 years. This is just a small percentage of what I actually have. The tooling that we made with the rail systems and the clamp systems we showed in the last video, a lot of that has come from scrap steel. But anyways, Randy wanted to know the process that we use to grind and square up these blocks, and so I had some leftover steel from making these rails. We made them out of A2, and I thought that I would go ahead and make a couple more setup blocks. And I'm just going to take a break. Well, actually, before I take a break, I'm going to clean this table up a minute here, but one of the other viewers, Steve Canny, when he was watching our video on our sign plate, he was wondering how I measured the 10-inch distance on between the rolls there with just a 81-piece gauge block set. And as I was talking, I was telling him that some of these blocks I make, like these, I have 6 of these. I only have 2 of them right here. These are made exactly 4 inches. I have 6 of them, and so I didn't have to rely on all my gauge blocks. Just by stacking 2 of them together right there, I got 8 inches, and then I can use my gauge blocks. So when you make some things like this, hitting some nominal sizes sometimes work out real good, because if you get a big stack and it's real tall, well, now you can build these up. They're a little heavier. They're not going to fall over as easy. You can put your other gauge blocks on top, and it works really nice for getting them tall measurements. And so I will grind these, and I'll get them flat, parallel, and square with each other, usually less than about 1/10. We usually do many different things. One of the things we do, like on these blocks, they're match set, and this is what I use for training my son Michael with on grinding. He machined and ground these up. But we have a 9/32 hole on this side for clearance for a 1/4 20. And we have a 1/4 20 tap on this side. So this works real great. If you want to come over here, and you can use your clearance hole, and you can bolt this, you know, act as a rail system or whatever on any of the tools that we have. So I'm going to clear this table off a little bit, and we'll come back and we'll continue with the new blocks I've made. You've probably seen on one of the Jonathan's videos, you've seen him grinding a block similar to this one right here. People that I've worked with over the years that are in grinding, this is probably one of the favorite tools that they have right here. We call them cubes, although they're not technically cubed because you don't have equal sides. It's, I guess, technically a square because it is square here. It's I think about 5 inches roughly. It's about a little over 2 inches that way. But anyways, this is precision ground. I did do a video on this earlier, and since then I've actually ground it in even more accurate. I think I had it within about 3 or 4 inches. It was within about 2/10,000ths. And now just about in this entire length, it's less than 1/10. Some of the sides you can't even measure with the indicator. And we used the method that you will see if you look at one of the videos called Jonathan's Cube. Also, it's a method that Randy Richards was using when he's grinding up his square. Don Bailey's done a video on that as well. He gives you all the details about that. But it's a very precision way to get stuff square, flat, well, square with each other. You have to get your flatness and parallelousness just with your normal surface grinding. We use this cube a lot when it comes to squaring up blocks. And these are the 2 little parts that I've made right here that we're going to grind today. We'll use this cube. We'll use it for the purpose of grinding these 2 edges, getting them square and perpendicular with each other, and with the sides here. I do have a precision vise. This one is really good. It's very accurate. I like using it on some stuff, but I prefer using this cube whenever I can. It's a lot easier to use. I can get things more accurate in it, as well as measuring what I need to tell how straight they are. Items are sitting on here. It's easier to do on here. The things that you have with the vise that you can run into problems with, you get your center point of pressure. Your center point of pressure when you tighten the screws right here, running down that way. So if you have your part sticking up on the edge and you're tightening up, you're getting a little twist with the play in there. It can be uneven clamping pressure, and it can affect the accuracy of your part. We've done a video demonstrating this on the milling machine with a Kurt vise, and showing just how far these our dimensions can move by the proper placement, you know, of your part in the vise. If you're on the outside edge, you're always best to have something of similar length on this other side, so when you tighten, everything's even. If you're going to tighten stuff without something that's similar size on the other side, you're going to get distortion. When you're using a block like this, you don't have that problem so much. What you got to work on is the positioning of your finger clamps and how you hold the part if you're going to hold it on there. If you got some finger clamps holding your part on, the positioning of them finger clamps can actually change the part going this way, and so you have to check everything out. And that's the thing with grinding. A lot of times the grind process doesn't take very long at all. And what takes place is it's your setup time, and your setup is where you want to focus on, because your setup is where you're going to get your accuracy. And if you have multiple parts, if you have the proper setup techniques, you can really cut a lot of time out on your projects. But anyhow, we designed these little clamp systems, rail systems. What we're going to use these for are in conjunction with this cube, as well as the faceplate I just made. And one of the things when I make my tools, I always try to use 1/4-20 taps or 1/4-20 clearance, because I like to make my tools so that I can use them on the other tools. And so I always go with a 1/2 inch pattern. So from this hole to here is a 1/2 inch, from here to here is a 1/2 inch, from here down to here is a 1/2 inch, and so forth. And so if I make my counterpart tools with that 1/2" hole pattern, they'll work out good. And sometimes I might not be able to get a 1/2". I might go a hole here, and then I'll go 1 inch, and then 1 inch. But I always try to make it so that I can have increments. So anything that falls within the 1/2 inch, you know, a 1/2 inch, 1 inch, 1 1/2, 2, that I can make my tools to match that. And so what I've done here, I've actually made this unit where I made slots going this way and slots going this way. So I can use this as a setup tool if I have multiple parts. I can set this up, and then you kind of use it as a rail system that locates the parts in. And I'm just going to throw some screws in there. I'm not going to clamp it down, but just to show the movements that you can get. And you can see I can get all kinds of positioning. These slots are designed so that I can get the screw. If it's over here, I can put another one down here. I can hit any increment, so there's no area on this cube. In other words, I can put this up to whatever place I want. I'm not going to be limited by my screws stopping me before I can get that last 10 thousandths or whatever I might need to get my part raised up. But anyways, a lot of times what you'll do is you use tools like this for setup purpose. You indicate them in, you bolt them down, and then if you have multiple parts, you can slide something like this in. Say if you have multiple parts and you had to clean up that in, you can toe clamp them in, turn your cube up, you know, clamp your part in, grind it off, set other stops up. Just a nice handy little system that works together when you make your hole patterns on that 1/2 inch increments. So anyways, what we're going to do, we're going to start off by grinding these flat, getting them flat and parallel. I already checked them under the indicator, and they're real flat. But when I milled all the material, we got a little twist and distortion in that, which is understandable. But they're flat right now within about 1/1000ths. And so the method that we use on the mill to get things flat, parallel and square, is very close to the method that we use here. We always start grinding the widest surface first. And the reason we grind the widest surface, so it's going to be here, making this flat and parallel. This one, making these surfaces flat and parallel. The reason we do that is because when we locate these parts off of this block, we want as much surface contacting on there so that it will make, when we set this block up on the surface grinder and grind here, flip the block over, grind here, it will make a much more precision. If we would grind, say, these narrow edges first, and then we try to set this up and clamp up here and try to get this, well, you're going to be pulling this all over the place. It's going to be extremely difficult to get this face square and perpendicular with this face if we ground these sides first. So we always start with the widest faces, and then we go to the second widest faces, and then so forth. So let's move over to the surface grinder, and there's a few things I just want to show you on the grinder that might be of interest to you too. One of the things that many of you probably experience on your surface grinders is with your hubs. When you go to throw a 1/4 inch wheel, to put that on there, most of your hubs will come with a thin washer like so, and you throw it on there, and then you go and to tighten your nut on there, but it won't tighten. There's a lot of slop because the surface that you have, mine actually measures about 5/8 of an inch, and where the threads end over here, it's about 3/4 of an inch. So you need to have a spacer to use the 1/4 inch wheels. What I've done is I just made a spacer that would take up that gap. A 1/4 inch wheel is about the most narrow that I'll be using. I can put this thicker washer, pop it in there. Now when I go, the threads, they're below this surface on this washer, so when I tighten that wheel in, it's really good. Now I'm not going to grind with this wheel. I was just showing you that as a little thing that you can do if you run into that problem. What we're going to grind with today, we're going to use this Radiac. It's a 46 grit wheel. It's a G800, and it's the VOS, which means it's an open structure. And the reason I'm going to use that is because I haven't hardened the parts yet. But I'm going to grind these just for a demonstration on the method that we use on squaring them up. After I get them ground up and all that other tooling and hardware that I've made for our spin fixture, we'll send it all out together to get heat treated. When we send it together, we're going to be charged a minimum weight charge anyways, and so this way it will be cheaper for us. But these wheels work great on soft steel. They're really hard to load up. The thing is, we're just doing flat grinding. We're not bumping shoulders. If you try to bump shoulders sometimes with these porous wheels, they probably won't work as good as a closed structure because the edges will break down a little bit more. But for flat grinding, you can't beat them. And they grind nice and cool with that porous structure on there. And so we'll get this mounted. And what I do, even though this washer with a 1/2-inch wheel will work good, I never use it. I just use the thicker washer all the time. There, we need to turn on our 3-phase converter. We'll get things set up and we'll be back. Well, we have the wheel trued up right now. We cleaned the magnet off. I got the parts placed on there. Before we did that, I took these stones that we've made many videos of. And again, these originally, we found the idea from Robin Rensetti, the video that he made. You need to watch those. These things, as far as I'm concerned, are worth their weight in gold. A standard bench stone like this, if it's not been finished out with a diamond wheel, it will be very aggressive. And so your magnet, no matter how careful you are, you're going to get some slight imperfections on it. And what will happen is you need to take those imperfections, and before these stones, I would just take actually one of these Indian stones, and then I would just lightly go over it and try to move the little imperfections, the little scratches and whatnot. But by doing that, you're removing a little bit of material on the magnet at the same time, and so you end up having every so often to true up your magnet again. With these stones, they're designed by taking the diamond grinding wheel and getting all the peak points of the grit nice and flat. They're not aggressive. What they will do is they'll capture all the high points and they'll take them out. So you can bear down on these pretty good, and you're not going to be taking material off this magnet other than the high points. So I'd encourage you to watch Robin's video, and if you want a set of those stones, he'll show you how to produce them. I believe that Robin is actually going to start selling those stones in the future, so check out his site if you're interested in those, and see what he has to offer. When I put my parts up here, I got two different parts. I'm going to grind them together. They're the same height. If you have a bow in the part, you want to get the bow on the first side going like this so that it's high in the middle. I have probably about a 5/10,000 bow, not enough to worry about, but you can check for bow by pushing both in. Get it in there, get that bow up first, because if your bow is like this, your part will have a tendency to rock on you as you try to grind it out. If you have the bow this way, you're grinding the middle part and it's stabilized with the two ends. So I have a variable magnet. I'm going to turn that on, and I have it set very light. And what I'm going to do is I'm going to have that magnet and try to set it so light that you can still move the parts, but I got a little bit that I can hold. And when I come and touch the parts, I'm going to take very light cuts. Now you got to be careful. It can be dangerous, because if you don't have enough magnetic pull on here, you're going to throw your parts off. They'll slam into the guarding here. A lot of times people will block these in, but if the magnet's light, you're really not getting a lot there, and you're just going to have more parts flying. I prefer on things like this, instead of blocking them in, because I'm using a light magnet, is to let it slide. If they slide, a lot of times they'll just slide a little ways and stop. Sometimes they'll slide all and hit the back guarding. It all depends on how heavy of a cut you're taking. So if you take light cuts, you're going to be better off. There, right there, I just got it. I mean, you can move them around a little bit, but not much. We're going to come down and we're going to touch off. I took about 1/1000 to clean the surface up, whereas 100%. I'm at 1.3 because I took just a couple tenths for a finish pass. But I just wanted to stress this, when you do your milling work, the more accurate that you are on your mill as far as your flatness, the easier it is to grind. If I had these things and they were bowed real bad, or if they were way out from one end, 5,000 from one end to the other, I'm going to spend a lot more time grinding. This ground up really fast because, like I say, everything was less than a thousandth coming off the milling machine, and it took about 1/1000 to actually get everything cleaned up 100%. So I'm going to turn the magnet off. I'm going to flip this upside down after I clean everything off, and I'm going to grind the other surface. And then what I'm going to do is I'm going to turn the grinder off, I'm going to clean it off again, and I'm going to flip it back to my original side and clean with just a few tenths and clean up. And the reason I'm doing that is, right now I took almost all of the twist, the bowl, everything out on this side, but there's a little bit in there yet. When I flip it over, I'm going to take out, again, all that twist and bowl. It'll be down probably to the 10th. I'll take that out. When I flip it over again, I'll get it closer every time I flip it. And so one of the things when you're working on thin plates like that, it's flip, 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 flip. And you can work that out with light magnets every time. And then you can work all those imperfections out. Sometimes you have to go to other extremes. We've done a video where you've seen I've ground hard parts that had bows in them. It was about 130,000 thick plate, I believe. We're using paper towels underneath there to take that bowl out, and that method will work real good. There's other methods that people use, newspaper, thin sheets of rubber, things like that. I'm just wondering, and I haven't tried it, but I'm just thinking a lot of those latex gloves that you wear, I'm just wondering what would happen if you would cut a little piece of that your shape, if you got something with a bow in, and try putting that on there. I think that would work good, and that might be something we'll have to try in the future. But we'll get back. We're going to cut off for a minute. I'm going to get everything cleaned off, get everything set upside down, and then we'll grind the other side.